Hello and welcome to Nation Innovation. Today we are going to start with 8051 microprogramming, and the programming will be in assembly language. So basically assembly language is a low level programming language that is used to write program code in terms of mnemonics. Even though there are many high level languages that are currently in demand such as Python, but assembly language programming that is used in many applications. For example, it can be used for direct hardware manipulations. Also, assembly language is used to write the 8051 programming code efficiently with less number of clock cycles by consuming less memory as compared to other high level languages. So in assembly language, what we have is we have source file in the form of .asm syntax. Then we have assembler. This assembler converts this source file into object file .object. Then we have a linker which generates the executable file. Assembly programming language is fully hardware related programming language. The embedded designers have required sufficient knowledge on hardware of particular processor or controller before writing the program. And since the assembly language is developed by mnemonics, therefore users cannot understand it easily to modify the program. Hence it is a bit secured. Assembly language is developed by various compilers and Keel Microvision is best suitable for microcontroller programming development. So assembler converts the assembly language to binary language and then stores it in the microcontroller memory to perform the intended task. Now 8051 has CISC type of architecture. CISC, that is complex instruction set architecture. It is 6 based Harvard architecture and it has certain peripherals such as 32 input output peripherals, then timers and counters, and serial communication and memories. And register is the main part in the processors and microcontroller which is contained in the memory that provides faster way of collecting and storing the data. Now let us start with the assembly language. So assembly language has some basic rules. For example, all the labels must be followed by a colon. The labels which are defined in the program, that should be followed by a colon. All symbols and labels must begin with a letter. Then comments can be typed in the lowercase and last line of the program must end with end directive. For example, if we have a command, let's say move a comma b. So this move is the opcode or the mnemonics. This a and b are the operands. Now this opcode is a single instruction that can be executed by the CPU. Here, for example, move is the opcode. Then we have elements of assembly language programming. So elements of assembly language programming, there are basically three. First is assembler directives. Then we have instruction set. Then we have addressing modes. Now assembly directives. The assembly directives, they give directions to the CPU. 8051 microcontroller consists of various kinds of assembly directives to give direction to the control unit. For example, ORG, that is origin, it indicates the start of the program. Then we have DB, which is defined byte. Defined byte is used to allow string of bytes, for example, printing. Then we have equivalent, EQU. Equivalent directive is used to equate address of the variable, and end, which is used for end of the program, end directive. Now let us move to addressing modes. So the way of accessing data is called as addressing mode in microcontroller. The CPU can access the data in different ways by using different addressing modes. Basically, 5 addressing modes are there. So the first one is immediate addressing mode. In this, the source must be a value that can be followed by a hash, and destination must be special function registers, general purpose registers, and addresses. It is used for immediately storing the value in the memory registers. For example, we have move a comma 20h. This means A is an accumulator register and 20 is stored in the A register. Or move R0, 15. This means R0 is a general purpose register and 15 is stored in the R0 register. Then move P0 hash 07H. This means P0 is a special function register and 07 is stored in P0. Then if we write move 20H, hash some number is 05H, it means 20H is the address of the register and 05 is stored in the register which is addressed at 20H. Second, we have register addressing mode. In the register addressing mode, the source and destination both must be registered and both must not be general purpose registers, so that the only inhibition is the data cannot be moved within general purpose bank registers. For example, if both are special purpose, for example, move A comma B, A is a special function register, B is general purpose register, then this data can be transferred. But if I write move R0 comma R1, so this will be invalid instruction because to general purpose movement is not possible. Third one is direct addressing mode. So in direct addressing mode, source and destination must be an address but not value. Both source and destination must be address and not value. For example, move A comma 20H. So 20H is an address and A is a register. So this is fine. If I write move 00 comma 07H, that means both are address of general purpose registers. So this is fine. And if I write move 07 comma 01H, move A comma 08H. These are all examples of direct addressing. And then I write add A comma 07H. That means the final value which is stored in A will be A plus 07H. Then we have fourth type of indirect addressing mode. So in the indirect addressing mode, the source or destination must be an indirect address but not a value. And this supports pointer concept. This supports the concept of pointer. And pointer is only used for R0 and R1 registers. For example, move 20H comma at the rate R1. That is, one value is stored in the 20H address of the general purpose register. So whatever will be the value of R1, that is stored in the 20H address of the general purpose register. Then move R1 comma 08H. So here R1 is the pointer variable that stores the address of R0. That stores the address of R0, that is 08H. Last one we have base index addressing mode. Base index addressing mode. So in this addressing mode, it is used to read the data from the external memory or ROM memory. All addressing modes cannot read the data from the code memory. The code must read through the DPTR register, and DPTR register is basically used to point the data in the code or external memory. For example, here move CA comma at the rate A plus DPTR. C indicates the code memory, C indicates the code memory, or if we can add move X A comma at the rate A plus DPTR. So here X indicates external memory. So we will continue with more programming in the next lecture.